Hello and welcome to Section 10, Delivering Published Desktops with Horizon. In this section, we're going to look at how to install and configure Horizon to deliver published desktops to our end users. So what are we going to learn in this section? In this section, we're going to take a closer look at how Horizon can deliver published desktops. We'll start off by looking at the architecture and how to size an environment. Next, we will start the installation process by configuring an RDSH server to run the desktop sessions and also installing the Horizon agent to enable the RDSH server to communicate with the View connection server. The connection server will act as the broker to the desktop sessions hosted on the server. Next, we will configure the Horizon elements of the solution, creating a farm that consists of the RDSH servers and then a desktop pool that contains the desktops that the users can then access. Once configured, we will look at how you can load balance desktop sessions across multiple RDSH servers, and then look at how to make the server operating system look a little bit more like a desktop operating system. Finally, we will log in and launch a desktop session as one of our end users. So now let's move on to the first video of this section and look at the architecture of publishing desktops with Horizon and how to size an environment. In this video, we're going to talk specifically about the architecture and how to size an environment, as well as how desktop sessions are load balanced using the default method in Horizon. So let's just remind ourselves what exactly we mean by desktop sessions and how that differs from VDI. Desktop sessions, often referred to as server-based computing or SBC or remote desktop services RDS, often get confused with VDI. So what are the differences between these technologies and VDI, if any at all? So the difference here is that with session-based desktops, the end user is connecting to a Windows Server operating system that's configured for a multi-user environment. The user connects to their own individual, separate and protected session of that server operating system, effectively sharing it and having their own little slice for the time that they are connected. In a VDI environment, a user is connecting to their own dedicated version of a full-blown desktop operating system that is not shared with anyone during the connected session. So why use this model instead of VDI? Well, it depends on what the user is doing, really. They may well be a call center type user, whereby they don't need the full power of a desktop OS. It obviously lowers the cost of management, as you won't need to manage a full desktop OS and all the patches and updates that are involved in doing that. All you need to make sure is up to date is the central server OS. The one thing to watch out for, though, is that as they're running a server OS, you need to look carefully at compatibility between the desktop OS versus a server OS. Some things may not work and some applications might be a little bit upset running in a server environment. So how does the hosted desktop feature work? Let's look at that at a high level. To begin with, as with connecting to any other View delivered virtual desktop machine, you launch the View client and log into the connection server by entering the details of the View connection server that you want to connect to. The connection server responds, asking the user to enter their username and their password. The username and password information is then passed back to authenticate against Active Directory. The connection server holds the configured farm information that contains the details of the available desktop sessions, which are read directly from the Horizon agent that is installed on the RDSH servers. A list of entitled desktop and application pools is then displayed to the end user in the View client. The end user can then double-click on either a desktop or an application to launch it. The connection is made, and the application or desktop is then opened in a new window. So let's take a look at some of the sizing. For the total memory in each RDSH server, VMware recommends that a virtual server configured as an RDSH server should be provisioned with 64 GB of memory, and in terms of CPU requirements, the VMware recommendation is to create virtual servers for the RDSH role and configure each one of these with 4 virtual CPUs. Make sure you do not overcommit on the number of CPU cores though. So for example, if you had a virtual machine running as an RDSH server, configured with 64 GB of memory that had heavy users hosted on it, you'd be able to host a maximum of around 64 user sessions on that server. For the hardware configuration, let's say you had a physical ESXi host server configured with a 2-socket CPU with 12 cores, giving you a total of 24 cores. This would allow a maximum of 6 RDSH servers, as we're going to provision virtual machines for the RDSH role, each with 4 cores, and each with our 64 GB of memory. That would mean that the physical server would need to be configured with 384 GB of memory to each host the 6 64 GB sessions. These figures are only guidelines, and based on some of the VMware recommended best practice, it's always best to run an assessment on your environment to work out your optimum configuration and what is actually required. Next, we're going to look at load balancing the desktop sessions and how load balancing works. By default, which server provides the resources for the session is purely based on how many sessions are available on any given RDSH server at the time of the user request. So that means when a user logs in and launches a desktop session, that session is delivered from the server that has the highest amount of free sessions available. That is to say, it's the one that's not the busiest. So in this example, we have two RDSH servers in a farm. RDSH server number 1 can host a maximum of 100 sessions and currently has 50 of those 100 sessions active. Then we have RDSH host server number 2, and that can host a maximum of 50 sessions and currently has 25 of those 50 active. Therefore, in this example, when we launch a new session, as the most free sessions are on RDSH host server number 1, this session will launch and be delivered by this server. So this is where a second option comes in, as it uses a more in-depth information to place sessions, which is based on measuring the CPU and memory utilization of each host, rather than the number of free sessions. To enable this load balancing method, there are a number of manual steps you need to complete, which we will work through later on.